Our topic for today is called hypothesis testing, and it is part of statistical inference. In statistical inference, it's what can I infer, what can I generalize about what I see in a sample about a population. Under estimation, our definition of infer was, what do I forecast, what do I predict? In hypothesis testing, it's what can I prove? What can I conclude about the population? I've made money using this topic as an expert witness because obviously when we go to court, we have to prove something. It's not what do I think, it's what can I prove beyond a reasonable doubt. And I've been an expert witness in like 4 cases where I went in and gave statistical evidence and concluded that this is the case with overwhelming evidence proving it. So it's not what do I think anymore. That was estimation. It's what can I prove beyond a reasonable doubt. As always, we start with an illustration. Page 25, number 1. Diuretic is the president of Herbadeth Products. Di has issued a press release concerning the new herbal weight loss product called Lard Lifter. Great title, great name. The press release claims that the average user of the product lost 15 pounds in the first month. We took a random sample of 36 individuals who were using this product, and we found that the average weight loss was 13 pounds during the first month, with a sample standard deviation of 6. Can it be proved that Lard Lifter is not as effective as advertised at the 0.01 level of significance? Can you prove that Lard Lifter is guilty of false advertising? That's the question. So it's not what do I think? What do I think the average loss is? Well, what do I have here? Okay, so as always, we start with our notation. First thing I need to know, is this quantitative data or is this qualitative data? What question was asked 36 times? How many pounds did you lose? And I get back a number I can do arithmetic with. Quantitative data. Do I know how many people are going to use it? Nope. Do I know the average weight loss of all of the users? Nope. I don't know the standard deviation, the variability of all of the weight loss of all the users. Nope. What did I see? I took a sample, 36. I saw the average weight loss was 13 pounds during the first month, and there was variability. Some lost 9, some lost 15. Variability measured by a sample standard deviation of 6. All right. A hypothesis test is a courtroom proceeding. And in the courtroom, you got a plaintiff and you got the defendant. The plaintiff files the case. This notation here, HA, which stands for alternative hypothesis. That's the plaintiff. You state this case first. If I'm going to prove false advertising, what must I prove? The average weight loss of all the users of this product is less than the 15 that their ad says. If I can show that, I can prove they're guilty of false advertising. So the first thing is, who's got the burden of proof? What are they trying to claim? Then you do what's called the null hypothesis, the HO. I wish they just called it plaintiff and defendant. But they did. But that's what they are, plaintiff and defendant. So HO, what's the defendant's claim? Oh, the defendant's claiming, oh, it's at 15 or it's at least 15. It's 15 or more. Whatever is the opposite of this is your null hypothesis. It's the opposite. If it ain't less than, it's greater than or equal to 15. So there's our claim. That's all you got to do. You got to do that part. The rest is cookbook. The rest is follow orders. And the orders are in the form of a handout that I have here in your workbook. So that's what you got to do. Okay, and then you put the level of significance, 0.05. What that means is I want to be 95% sure they're guilty before I rule against them. I want to be 95% sure they're guilty. I'll take an error factor of 5% of convicting an innocent person. Now, again, that's all you got to do. And then you go to this wonderful handout. Ay, caramba. That's but ugly. Greek festival. Okay, I know. Just go with it. It's just, believe it or not, this is your friend. This is going to save you a lot of aggravation. So I got hypothesis testing about quantitative data. I got hypothesis test about qualitative data. Our hypothesis test is about what? Quantitative data. Do we have one sample? Yeah, I got one sample of 36. Okay. Did we sample over 30? Yeah. Okay, so far I got a 1A. Okay. How did my alternative look? It was a less than. So I need to use formula 1A2. See that? That's the matchup to what we got right there. That's the matchup to what we've got going on now. Okay, so what this is the ground rules for the hypothesis test. You will reject HO. In other words, you'll say, I rule for the plaintiff and think the defendant is lying. That's what reject HO means. I will rule for the plaintiff if the z-test value is less than some table value in the normal table. So what's happening in a hypothesis test is the following. Like in our court system, the benefit of the doubt goes to the defendant. I believe you, null hypothesis. I believe you, manufacturer, that you are telling me the truth. I won't expect to see 15 pounds when I sample. I'll give you 14.9 and 14.8 and 14.7 and 14.6. I won't require it to be over 15. I'll give you some benefit of the doubt. But there reaches to the point where beyond that point, you're lying. And that's what we're finding here. Z-test is how many standard deviations our result is away from the manufacturer's claim. And Z alpha is a table value, which is 95% of the time we shouldn't see anything this extreme. So this is the most extreme we should ever see in number of standard deviations, and we compare that to what we saw in the sample. Well, let me show you. So case 1A2, reject HO if this is a true statement. If that is a true statement, we are going to reject HO and call the defendant a liar and rule for the plaintiff. Our level of significance is 0.05. So we need to look up the Z.05. That's the table value we got. And we looked up that earlier today. Two of our cases was a 90% confidence interval, and it was minus 1.65. What this means is I will tolerate up to 1.63, yeah, 1.64, yeah, differences between what you said and what I seek. But anything more extreme than 1.65, I conclude you're lying. So then we calculate this z-test value. Where'd that come from? Each of our four cases has a little thing here which says z-test value. That's how many standard deviations the defendant's claim is away from what we saw in our sample. And here's that value right there. You have to work that out. On the final exam, you don't have to work out, because I will say write the expression for z-test. You write that. Okay. We saw 13. They said it was 15. And we divide by 6 over the square root of 36. 6 is S. 36 is our sample size. And we get -2. What that's saying is that 15 is -2 standard. The 13 we saw is 15. Let me start over. The 13 we saw is 2 standard deviations below the 15 they claim. Can that be just due to chance? No, they're lying. Since -2 is to the left of -1.65, we reject the null hypothesis. We always give our ruling as it affects the defendant, just like in the court system. The defendant is guilty or not guilty. In this case, the defendant is guilty. I reject the defendant's claim. So we have proven with at least 95% certainty that they are guilty of false advertising. Last thing, how sure are we that they are lying? And that's a p-value. A p-value is, okay, what is the chance that they're lying? So how do I find a p-value? You set your, go back here, and instead of alpha, you write p-value, and then you put whatever you got as your z-test, -2, and you make it a little equal to sign, a little equation there. -2 equals z p-value. And then you say, okay, what does p-value have to be? If we look up -2 steps in our table, -2 steps is -2 steps, -2 steps, -2 steps. Right there is -2.00 steps. That is the 0.0228 percentile. So if I said, hey, look up the 0.0228 percentile, you say, oh, you need to step -2. So we got a little equation here. This subscript equals this. Our p-value is 0.0228. There is a 0.0228 chance that the defendant's telling the truth. And there is a 0.9772 chance the defendant is lying. Whew, we're done with hypothesis testing. What was that? Was that 20 minutes? 20 minutes on the dot. Thank you. Thank you. You are now card-carrying members of the Hypothesis Test Club. Club you didn't want to be in, but you are now in. You know how to do hypothesis testing. I know you don't believe it, but you do. Let's prove it. Let's do 2 more problems and then we'll go home. But first, let's go through this step by step one more time. Here's what you need to do on the final exam on the hypothesis test question. Establish your notation. Do we have quantitative data? We have qualitative data. Say, what do we know about the population? What do we know about the sample? It's what we do the entire second half of the semester. Next, read the problem. Say, who's got the burden of proof? That's HA. State what we're trying to prove in terms of a mu or a p. Mu or a p. You have to state your claim as far as a mu or a p. The average of everybody or the proportion of everybody. Okay, whatever's left is HO. Read the problem and see what the alpha is, the level of significance. How sure do we want to be before we convict somebody? Go to page 23 and 24 in the workbook. Look up the appropriate Z value. Calculate the Z test value. Make your decision. And if required, find the P value. That's it. All right, let's show you that you know how to do hypothesis testing. The student newspaper at a state college, I didn't put CSUN in there because I don't want to be sued, just published the results of a recent student poll concerning the proposal that all locker rooms become co-ed. Whoa, I'm for that. In this poll, 100 students were sampled and 80 students stated they were in favor of the proposal. Whoa. The college president, Miss Prudence Righteous, we don't get along very well, quickly ruled against the proposal, claiming that the sample did not prove beyond a reasonable doubt that a majority of the students favored it. In fact, she claimed that excessive amount of business students were polled. Known perverts were polled as part of this study. If the level of significance of 0.05 again is used, we can the students disprove the president's claim? Okay, here we go. Number one, put down your notation. Okay. What question was asked 100 times? Are you in favor of co-ed locker rooms? What responses did I get back? Of course, no. Hell yeah. Whatever. So we get back yeses and nos. That's qualitative data. Are we ever going to do a census and ask everybody on this campus? What do we got, 40,000 now? They're huge. Their opinion on this? Of course not. We'll never know P. Took a sample of 100. 80 out of 100 said, yeah, I'm in favor. Okay. So we got the notation down. Next, what are we trying to prove? Student newspaper is trying to prove what? That the proportion of students in favor of this proposal is a majority. What's a majority? Anything, not 51%, anything over 50% is a majority. You get 50% and one vote, you win. Okay, so that's what our argument is about. Is it a majority? Is it a majority? 50% is a majority. So the student newspapers want to prove that. And of course the president is saying, oh no, it's this. Less than or equal to 50% of the students are in favor of this awful proposal. All right, so now you've done your part and the rest is just follow orders. Just slow and methodically, like the good CSUN sloths you are, walk through the process. It's all laid out for you. I go to my wonderful handout here, you know. So we have quantitative data. Did we take one sample? Yeah, I took one sample of 100. So it's a 3. It's a case 3. So on your exam, write case 3. Did we sample over 30? Yeah. Write 3A. And which one was our alternative? A not equal to, a less than, or a greater than? It was a greater than 50% is what we're trying to show. So here's our sample, here's our target, here's what we're gonna do. This is how many standard deviations our sample result is away from her claim, and this is our tolerance. Our tolerance is Z1 minus alpha. We reject HO if this is a true statement, if this number of standard deviations is more than that number of standard deviations. So, here's what I got from page 24. Reject HO if Z test is greater than 1 minus Z1 minus alpha. I plug in alpha, 0.05 again. Okay, when you publish research, 0.05 is the absolute minimum that you can get away with Most research is published at the 0.01, 0.001, 0.005 level of significance to get good research published in any kind of reputable journal. So plugging in alpha in here, 1 minus alpha is 0.9, 1 minus 0.05, which is 0.95. If you look up 0.9500 in the tables, you'll get 1.645 steps to step up. So we have to be more extreme than 1.65 standard deviations to the right to prove our claim, to prove the president is wrong. Here's my formula for the z-test. How many standard deviations of difference do I have between my 80% that I saw and the 50% that the president claims? Plugging in this value, I will say write the expression for z-test. You write this, and I will say use z-test equals 6 to make your decision. Is 6 greater than 1.64? Absolutely. We didn't just prove it. We crushed it. We knocked it out of the park. Okay. Is 6 greater than 1.64? Yeah. Reject HO. The president is wrong. The president is not telling the truth. A majority of students do favor it. Could I find the p-value? No, because if I looked up plus 6 standard deviations, we're literally off the charts. I can't even find a p-value. It's so extreme. So we're 99.99999% sure that the president is wrong. We can't even figure out, given the tables that I provided you with. The end. We proved it. All right, I got one more practice and then we'll go to the main event of the day. One more problem. Let's see if you can get this and we'll go home. Page 27, number 10. Al Brand is product manager for a high fiber cereal called Fleet Flakes. Al has just announced the release of a new improved Fleet Flakes with extra fiber. What was that other one I did? Turbo Colon was the other cereal. I vary between, I either have Turbo Colon or Fleet Flakes every other day. They're both, never mind. Okay. Al has announced the release of a new improved Fleet Flakes with extra fiber. A box of 100, sample of 100 boxes of the new cereal showed an average of 190 grams of fiber, standard deviation of 20. Took a sample of 125 boxes of old Fleet Flakes. Average was 185. Sample standard deviation of 25. What question did I ask in the first study? How much fiber does the new Fleet Flakes have? And I measured it with some kind of grams here. I measured it in grams. Can I do arithmetic with that? Yep. Quantitative data. So will I ever, I don't know how many boxes of new Fleet Flakes have been produced, so I could find that out though. Will I ever know mu? No, we've already sold it to people and they've already eaten it. Never gonna know mu. It's impossible to do a census. Okay, so when we produce stuff, we sample it a little bit to see if it was good quality, we sell it, and we keep a little bit in case we get sued to prove that it was safe. And so we have quantitative data, and I have a sample from the new Fleet Flakes, 100, 190, 20, and a sample from the old Fleet Flakes, 125 sampled, average 185, and S25. So what do I think? I think that the new Fleet Flakes is around 190, and the old Fleet Flakes was around 185. So I think we added 5 more grams of fiber in the new Fleet Flakes. What else? My standard deviation is better, is lower, right? That's good. It means we're producing a more uniform product. The standard deviation in manufacturing is our enemy. We don't want variability. Variability is fun in your social life, not in the production of goods. Here we go. Can we prove? I want to go on TV and do one of these commercials that say, scientific testing and independent labs prove with 99% certainty that the new improved Fleet Flakes has more fiber. That's what I want to be able to go on TV and say and not get sued. Can I do that? I don't know. Let's see if we can prove it. What am I trying to prove? I'm trying to prove that the new Fleet Flakes, the average fiber in the new Fleet Flakes is more than that of the old Fleet Flakes. I think it is. So that's what we're trying to prove. That's the alternative hypothesis. What's the null hypothesis? That is the opposite of that. That it isn't better. It's the same or less. My level of significance, 0.01. I want to be 99% sure I'm right. I head to this fabulous new handout here. Quantitative data? Yep. One sample? No. Two samples. One from the old, one from the new. This is your classic research. Control group gets the placebo. Experimental group gets the stimulus. Okay, so here is what this is classic research. This is how they do classic research. They use hypothesis testing. It's a two, no, Roman numeral two sample. Are both our samples over 30? Yep. Is it a 2A, a 2A1, a 2A2, or a 2A3? We're trying to show that the new one is more than the old one. We're trying to show our sign points that way, greater than. It's a 2A3. Here's my test, and here's the formula for my z-test to say how many standard deviations apart are these two results. So I look up, my alpha is 0.01. It says for me to look up 1 minus 0.01 or 0.99, look up the 99th percentile. Let's do that just for the heck of it. Find me the 99th percentile. 99, oh, too far. 99th, there we go, 0.9901, first one bigger than or equal to 0.9900, 2.33 steps. 2.33 steps to the right. So in order to prove it, I have to exceed 2.33 steps. How many steps apart are the two results? 190 minus 185 over that stuff, 1.67. Is 1.67 greater than 2.33? No, it ain't. You have to accept the null hypothesis or reserve judgment. We rule for the defendant. Can I go on TV and say, no, you cannot. You are not 99% sure that the new Fleet Flakes has more fiber than the old Fleet Flakes. You cannot show that. Well, what could I go on TV and say? What can I say? That's the p-value. P-value is what you can go on the TV and say. Find the p-value. I look at the test I just ran for the alpha. I put that with p-value. And the z-test, I plug in whatever z-test value I got, because it was 1.67. I look up 1.67 in the tables. I look up 1.67, 1.67, where am I right here? 1.67, there we go, 0.9525. Okay, and I get 0.9525. So if I told you to look up the 95th 0.9525 percentile, you'd say walk off 1.67. So these subscripts, you set them equal to each other. 1 minus p-value equals 0.9525. Solve for the p-value, and it's 0.0475. We can go on in TV and say we are 95.25. Scientific testing in independent labs proves with 95.25% certainty that we have more fiber in the new improved Fleet Flakes. Somehow that doesn't sound as good as being 99% sure. So what should the makers of Fleet Flakes do in this problem? Get this right and we can go home. I can't wait. They should take a bigger sample size. We're quite sure of it. Our ace in the hole is we control the sample size. If we took a sample of 400, we'd prove our case hands down. The bigger the sample size, the more sure we are of something. So just take a larger sample size, you'll prove your case. Practice problems are page 27, number 11, 38, number 13, 25, number 3. All right, next week, 10 to 11, starting at 10 o'clock, normal distribution review class in here if you need it. At the end of next week's lecture, if you missed points on the normal distribution, you can make them up. Because of the fact that there were some misconceptions about what I was asking for on the normal distribution problem, the fact I gave you the 5 choices, circle 1, and some of you applied that to the whole problem. Okay, I'm going to give you a redo on that. All right, here we go.